strategy was just make a T-chart so we knew what it looked like. And we essentially did a T-chart for each piece yesterday so we could put them all together. Today we are looking at one specific type of function. It's called the greatest integer function. I think Mrs. Keller a lot of times said the step function when you had this. We are not going to do a lot with it. So we're doing it today, okay? We're going to do homework over it today, but I'm really not going to hit it a lot after this. So it's one of those things that I have to show you guys, so I'm going to show it to you. It's ugly, but it's not necessarily hard, just plugging in numbers.
When I remember it from last year, it wasn't that bad. You literally just picked numbers and then typed it into your calculator and you had to graph it. But
so what the greatest integer function does is you put in a number and it will give you back an integer. Integers are like positive and negative whole numbers. So -3, -2, -1, 0, 1, 2, 3. You cannot get out something bigger than what you plugged in. So if I ask you to find, part A, the greatest integer of -5. Okay, greatest integer gives you the largest integer that is not bigger than what you put in. If you put in an integer, that is the answer you get back out. So -5 is an integer, so the answer is -5. It doesn't change. When I say part B, 2.46.
okay, but is this like this is obviously rounding, but like, isn't it like whatever the first decimal place is closest to?
It's not, okay, so 2.46 falls between 2 and 3. You don't go to the closest one, you just go to the smallest one.
Oh, I remember this. Yeah.
So it would go down to 2. If I said the greatest integer of -6.5. So if you graph that on number line, -6.5 falls between -6 and -7. Give me the smaller one.
Which would be -7.
So it always goes down, the smaller number.
I always mess up on the numbers.
I know, negatives are hard, and a lot of times, like you'll even see me, I just draw out a number line just to make sure.
What if it's like 8.9?
It doesn't matter, you'll still go back down to 8.
That's ridiculous.
It's so weird.
just forget
that.
rounding.
Yeah,
Cause
I
rounding,
remember
just
like
forget it.
Cause that's what like, I remember Miss Keller said something about it to us last year. She was like, y'all are gonna try to round, but you're not actually, you don't round.
No, it always goes down. Like think about, I got an example later about like a parking garage. You know, you pay so much money when you first enter the garage, and then you have to pay extra for every 30 minutes or something. If you pay one flat rate for the first 30 minutes, it doesn't matter if you stay 1 minute or if you stay 29 minutes. If it's still less than that first 30 minutes, you're just paying that one lump sum. So they don't round to the nearest one. It's just like once you hit this mark, then you pay more. But until then, you're still paying the flat rate. So the graph of this, we're going to graph the regular one first, and then we will look at a few more to practice. So the strategy with the greatest integer function is to make a T-chart. Unlike a lot of our functions, you are going to want to put in some decimals here because the greatest integer function rounds those decimals. Are you paying attention to me? I'm trying to take off your nails.
Hey, I'm messed up.
Me too. Like, I'm so listening.
Okay. Yes.
So this is the one where it's like open circle, small line, closed circle, open circle.
Yeah. We have to figure out which end the open and closed is on and how big the step is.
Yeah.
And so really once we figure out one complete step, we know what they all look like. So we'll start if we just plug in 0. So then I have the greatest integer of 0. 0 is an integer, so that's what we get out. So 0, 0 is on our graph. On these, guys, don't try to make your graphs too small. It will help you to kind of space out your x's and y's when you graph these. That's why I didn't put the actual grid paper. I just put some lines. So if I put in 0.5.
Why do you have to put it in that box first? Why can't
I'm just showing you what I'm doing, you don't have to write that. So the greatest integer of 0.5.
0.5. I mean 0.
Mhm.
0.5. Oh, these are like, there's a whole bunch that are all the same answer. So funny.
She knew what she was talking about.
So then if I put in 0.9, what's the greatest integer of 0.9?
0. Can you stop doing that? Or do you have to?
So what happens when I put in 1?
1.
We get out 1. That was an integer exactly. Now, we're going to say on this step down here, all the way up until 1. So 0.9, 0.99, 0.999, we're all down here. So to show that, we end it with an open circle. And then you jump up. And that's really what you need to get the graph. So now I can see that my closed circle is on the left, my open circle is on the right. My step was 1 unit long, and then I moved up. So then the pattern would just continue. You could keep plugging in points if you wanted, or I could just realize in the greatest integer, all the steps are gonna look alike. So this point would stay here until you got to 2.
Why is there a dot on 1 and then 1?
Okay, why do I have the open circle?
Wait, what?
Because that's like the last thing that we put in before it's not 0 anymore. Yeah, but why is it on the 1 if it's 0.9?
Because I could get smaller than 0.9. I could do 0.99
So
or
it's on the 1.
0.999.
But you can't, and it'll still be 0, but you can't hit 1.
So you
Like,
put it
one
on
is
the
not
1 though.
included, that's why.
We put an open circle there just to show we're gonna stay down here all the way up to this point.
Like, 1's not included.
1 isn't included because when I put in 1, that's when I jumped up to the next bit.
I missed something. Oh no, I know. It's quiet.
When I ask you to graph these, I will ask you to do a minimum of 3 complete steps.
Only
You
3.
could do more if you wanted, so we could continue this every way. After those 3, what I would appreciate is if you don't go all the way to the edge of your graph, just put dot, dot, dot to show me that you recognize the pattern continues. So I'm not gonna make you fill up the whole graph, just 3 complete steps and then you
So
can put
dot,
it
dot,
back.
like you did?
Yep.
Yours.
Domain.
Time out, can we just stop for a minute?
Also, I have a question.
Our X's. I'm only going to do the domain and range on this one, I'm not gonna do it on all of them.
So we won't have to do it for homework or anything?
So, like, this step hits everything until here, but then the next one picks up, and then the next one picks up. So what X values are we getting?
All
Integers.
Why does that matter?
Domain, the X's, we're getting
Negative infinity, positive infinity.
everything. But our range, we're only getting the integers.
So integers.
What?
All
Yes.
integers?
Our
Yeah,
Y
I remember
values, these red lines have a Y value of -2, -1, 0, 1, 2. We never hit Y values in between.
Wait, is it gonna be like that for every single one like that?
For
That
the
is
opposite
integers.
domain and range.
At least I know when they get
Why is
big.
range not already? So we just have to put
Because you
integers.
should
Because
hit
it's
like
integers.
0.5 or
Emily.
0.9. You can only
What did I say?
hit
Stop talking to me, I was
those
doing this better.
integer values, the 0, 1, 2. The greatest integer function, whatever you put in, it only gives you an integer out.
I love how you're shaking your head like you understand.
She thinks she can't hear nobody.
Okay,
Don't
let's do
cry.
another one.
She's so fast.
Alright, so I have the greatest integer of 1/3 x minus 2.
Did you say that?
Fast. T-chart.
Alright, T-chart. I recommend starting with a nice point. I typically always start with 0. It gives us a good place to begin.
So how do you put those bars in your calculator? What is red so?
It is not fun to get to. It's easier just to think about.
I remember.
Okay, so if I plug it in, 1/3 times 0 is 0, minus 2 is -2. So we get the greatest integer of -2, which is
-2.
-2. So 0, -2 is a point on my graph.
Oh man, I gotta draw maybe a little bit of that.
What do you want to plug in next?
1.
Okay. So if I put in a 1, you can use your calculator for this part if you want. 1/3 times 1 minus 2.
Yeah, I got you a calculator because you're so sweet.
No, what did I say? Don't talk to me. I'll be with you all day.
What does that give me on the inside here?
17/3. can't
negative
round.
one,
Oh my
right?
god, yeah, I was gonna say -1.
This is like -1.67 if you plug it in.
Uh-huh.
So it's in between -1.
It's
and-
negative one
So
point six
-2
six
because
six six
-2
six
is the
six
smallest.
Mhm. So it's in between the -1, -2, you always give me the smaller one, which is still -2.
Please tell me there's not fractions on the homework.
Well, there's gonna be if you wanna plug in
How
stuff
is it
online.
positive two
Well, I
if it's
don't want
negative
to
one
do
point
that.
six six six
You
six
said
six
it.
six?
-5.
Point five, do point
You
five.
didn't know it was
It
it's
is
not
negative.
with the fraction.
Miss, do point five. Or
Okay.
can we not do that one?
Can we
We
not
can.
do?
Stuff like that.
Can you pick the numbers and pick numbers that won't come out as fractions?
Right.
You can, we have to figure out where our step jumps, essentially. So right here, I'm still down on this step, right?
Can we go to 4?
What if let's try maybe 2 and 3 and see if we
Wait,
can
weren't
figure
one of
it out.
those supposed to be an open circle?
We haven't got to that point.
Emily, calm down,
You're
bruh.
getting ahead, just wait,
Alright.
just wait.
Put in a 2. So 1/3 times 2 minus 2.
It's negative 1.333.
Yep.
Okay, so -1.3, that's still between -1 and -2.
Oh my gosh.
So we're still getting -2.
Oh.
So we're still down here on this step. When I put in a 3,
It equals negative 1.
gives me -1 exactly. That's an integer value. So 3 is when my step jumps. So that's a closed circle at 3, -1, because that's what I got out. So what do I have to put underneath
An
that?
open circle.
An open circle. So this time, because of that 1/3, my step is 3 units long. Then I jump up 1. So if I were trying to continue this pattern, this one would start at 3. If it goes 3 units long, it would stay there until I get to 6. And then it would jump up. Okay, or you could go the other way. You could go down and back 3. So my rule, I like for you to have 3 complete steps.
It would be opened on the one under the.
Yeah,
negative
that kind of does look like it's filled in.
My thing, my graph just looks so stretched out because I'm making.
Is that one supposed to be open?
Yeah.
That bad.
And just minimum of 3 and then put ... showing you know what's happening.
I'm glad I didn't come back to nothing too crazy.
I was gonna leave today too.
I'm glad you didn't.
Well, this is the only reason I stayed.
I knew you wanted to see me. Okay. Look at this one.
I'm gonna stop making my emails.
I'm not.
So, an express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it in the interval 0 to 6. So, this one, I didn't even give you the equation. I gave you a scenario. And I'm asking you to graph this one from 0 to 6. So I think I did put an XY axis on yours if I,
You did.
okay.
Wait.
Um,
You graph?
yeah. So let's draw this graph. That's still not straight, that's sad. Okay, so we're starting at 0, 1, 2. And I told you to take it up until 6. Alright, my y-axis, the minimum we're going to pay is $20. So I'm gonna count by 2s.
That's not a lot of money. Oh, for mail? Heck no, that's too much money.
Packages are expensive to mail. Yeah.
That must be tough on my mom.
Oh my
I'll
gosh.
be making her mail every day.
What?
Can I just do like 10 count by 10s or count by 5s or something?
You could, but we're going to be adding in some others here, so.
Did you skip one? Okay, that makes sense.
So I just counted by 2s and if the graph I gave you isn't big enough, you can draw a bigger one underneath it.
How many did you
I'm
come
making
by?
my own. Yes, you can make your own.
1, 2,
I did not want to make my own.
You only have 5.
I counted by 2s. 2, 4,
You
6,
don't
8.
slow, Mrs. Circle.
On me.
And she just laughs because she knows it's the truth.
Wait, what'd you,
Okay,
hold on.
sorry.
See, hang on, I got one more.
They start off charging $20 for everything up to 2 pounds. So if your package weighs 1 pound, how much are you paying? $20. If your package weighs 2
1
pounds
pound?
exactly, you're paying $20.
If it
Express
weighs
mail is
2.1?
fast mail, so you pay more.
1 pound, $20?
Yeah. If it weighs half a pound, how much am I gonna pay?
$10.
$20.
Emily.
What if it weighed a tenth of a pound? How much are you gonna pay?
Girl, I don't have
$10.
a tenth of a pound on my car. I'm confused on how you're graphing this.
Okay, I'm
Emily.
just talking about, it says.
Okay, we're basically doing a T-chart, but not
Yeah, I
right
just
now.
wasn't writing it down. Everything up to 2 pounds. Now, will you ever have a package that weighs absolutely nothing?
Yeah.
Yeah.
No.
Probably
What do
no.
you-
If you
it's
say
a paper.
one single piece of paper.
It has some weight. It may not
It's
be
the
pounds,
box that
but
it
Like
weighs.
ounces.
0.2 grams.
The box should be
So-
free. Yeah, they scam you with the box.
This will start at an open circle,
Right, I'm gonna put it in my own box, girl.
and then it's going to stay here all the way up to 2 pounds. Now, as soon as it goes over that 2 pound mark, what happens to your cost?
Oh, $32. $32.
$22.
$22.
It goes up $2. Okay, so it'll start at an open circle because we saw this one started. So after 2, we'll go up to 22. And we're going to stay there for each additional pound. So if it weighs 3 pounds exactly, you're still just paying $22. But as soon as it goes over 3 pounds, it'll be $24. And you'll stay there until you get to 4 pounds. And then once you go over 4 pounds, goes up to $26.
That's a lot.
It'll stay there until you get 5 pounds. And after it goes over 5 pounds, it would be $28. And we only had to go to 6. So we get to stop. So we didn't actually come up with the equation, we just graphed this particular scenario.
Yeah, I don't really like the scenario situation. That's
Me
okay.
neither.
I don't really like the word problem, so.
I don't really like these.
This is
I don't
kind
like
of how-
fractions or word problems.
Hmm?
I don't like fractions or word problems or graphing.
That's a lot of money.
You have a lot of dislikes.
It's only 3.
So if you're trying to mail something, you might as well just wait, cause that's so much money.
Cheaper to drive.
No, you wanna know what I really,
Yeah, 20 will almost fill my gas tank.
Let me
$20?
do
Nuh-uh.
one
$20
more.
is like that.
I want to do the Grace integer of negative 2x.
I think like 32 fills my
Sarah, can we just like, stop real
Yeah,
quick?
just draw it on the bottom of your sheet. So this will be my last example. Grace integer of negative 2x. So, what do we plug in first?
0.
0. Okay, if I put that in there, negative 2 times 0 is 0, so we get out 0. Oh, that is crooked.
Yeah, like my line is on your board.
I'm gonna make sure my graph.
Apparently I really struggle with these straight lines, guys. Don't judge me.
Don't worry, the only person I judge is Emily Osborne.
Okay, what do you want to plug in next?
1, please.
No, I'm gonna do 2.
Oh,
We do
my
it too.
God.
Can we please just do like 25 or something?
I think it
No.
would help us to maybe put in like a couple decimals.
Okay, we'll do that after 1. 1.2.
So if I
No,
put
we're
in
doing 0.5.
0.5,
We don't put-
what's negative 2 times 0.5?
You don't mess it up.
Just ask that. What's
Whoa.
negative 2 times 0.5?
Negative 1.
Negative 1. Exactly, so the Grace integer is negative 1. Okay, so I put in 0.5, and I got out negative 1. So I'm already on another step, aren't I? Let's try something in between the 0 and the 0.5 so we can figure out exactly what's going on. So if I put in like 0.25, negative 2 times 0.25 is negative 0.5.
0.
That falls between 0 and negative 1.
Negative 1.
So it's going to give me negative 1 still.
Point 75 is gonna do the same thing, and then you can put in 1 now, and then you get your next step.
Okay.
Like I said, we should have been there.
Yeah, but you're not showing pieces.
What happens when I put in a 0.1?
The same thing.
I get a negative 0.2, which gives me out negative 1. step all the way up to 0.5 here. Where's my open circle going this time?
Alright, 6.
Below.
Yeah. Because of the negative, it flipped my open and closed circles. So this step has my open circle on the left, my closed circle on the right.
We had negatives before and it didn't do that.
No, it's because I had a negative on my x to begin with. I
Mhm.
had, so this step was half a unit long.
Will it always be like that?
Yes. So there's like one on the homework that has the Grace Manager just plain negative x, and it's gonna flip that open and closed circle. So it just looks like this. Okay, so I am done now. Minimum of 3 steps, but dot dot dot, so it keeps going. So I am going to give you your homework. Quick modification on question 2, when it says give the domain and range, you can mark that off.
Here, you can have your notes back.
Can you read last night's homework before I start on this?
Yes, so mark off the domain and range on number 2. And then on the back, 4B, I think says domain and range, and you don't have to find that. You're doing, so you mark off 4B. I think
That's the whole process.
this was yesterday's.
Oh, which one?
So mark off 4B, and then on question number 2, the 4 graphs, you don't